All right. So good afternoon, class. So today we'll be looking at transportation problem, and we'll be looking at this example that we have on the board. We'll be solving this example with three different methods. So we'll be looking at the northwest corner method, and we'll also be looking at the least cost method at the northwest corner method. We try as much as possible to solve it with least cost method. And the last one is Rogers approximation method. Rogers approximation method. Rogers approximation method. So these three different methods of solving transportation problem help us to get the initial transportation cost. We might not be able to get the optimal cost, but we'll be able to get the initial transportation cost. And there are high possibility that the initial transportation cost can also be the optimal cost. All you need to do is to check for optimality of the initial cost that you have gotten. So in checking for optimality, you can use the stepping stone method and the Modi method. You can use the stepping stone method and the Modi method. The stepping stone and the Modi method. So these other two methods can be used to check for optimality of what? Of your transportation cost that you have gotten initially. So when you look at this transportation problem that is on the board clearly, you have a scenario whereby we have three different sources, and we have four different destinations. So we have three different sources and we have four different destinations. And if you look at the variables that we have here, we have for source 1, we have 7, 9, 18. And according to the information initially, we have demand and supply in 1,000. So which means that we can get 7,000 units of a particular product. So let's assume the product is microphone. So we can get 7,000 units of that particular product from source 1, 9,000 units from source 2, then 18,000 units from source 3. Then if you look at the destination, the point of needs, we have destination 1 in need of what? 5,000 units, destination 2 in need of 8,000 units, destination 3 in need of what? 7,000 units, while destination 4 is in need of what? 14,000 units. Now, when you are solving transportation problem, the first thing you try as much as possible to get is that you try and ask yourself, is this transportation problem satisfying the rim condition? The rim condition. When you are talking about the rim condition, what it means is that the total demand and the total supply must be equal. The demand and the supply must be equal. So how do you get to know that the supply and demand are equal? You add up what is here, you'll be able to get the total demand. You add up what is here, you'll be able to get the total supply. Now whatever you get must be equal. So here you have 16 plus 18, you have what? 34. Here you have 13 plus 7, which is 20, plus 14, you have 34. So which means that this particular problem satisfies the rim condition, and we can also say that is a balanced problem. However, in a scenario whereby it is not a balanced problem, what you are expected to do is to create a dummy, whether it's a dummy road or a dummy column. So if the peradventure the point of destination has 36,000 units that is in need of, then we have the source having just what? 34. So it means that we have to create another source with S4. That S4 is going to be the dummy source that we have created. But the cost of moving the product from that dummy source to every other destination is going to be 0, 0, 0. While the units that is going to be there that we can get from that dummy source is going to be the 2,000 units difference that we have gotten from what we have on the board. But eventually, if the demand is higher than the source, so okay, if the source and demand, you have to create a demand, and the difference is going to be there. Why the cost implication are going to be what? Zero. But in this situation, it is a balance problem. We call it a balanced transportation problem. It's not unbalanced, and we can solve with the different methods that we have here. So I said, firstly, we'll be starting with the northwest corner method. To see how far we can go, we look at the least cost method and the Rogers approximation method. Now, what is the idea towards the northwest corner method? The northwest corner method is basically on the geographical location of what? Of the source whereby you are using to meet up with what? The demands at the destination. So we are looking at it from the top right left corner here, where you have this first source meeting up with what? With the first demand here. And the idea is that when you look at this, the destination one, the demand for this destination one is what? 5,000 units. The source can only give what he or she has. Now the source has what? 7,000 units. The demand for this particular location is what? 5,000 units. Now the idea behind the northwest corner method is that you give onto this particular demand, this cell that we have here, you give to it whatever he or she is demanding based on the capacity of the what? Of the source. So in that case, what it means is that if the destination one is demanding for what? 5,000 units, and source one has what? 7,000 capacity to give. It's going to give what? 5,000. It's 5,000 that is going to give. Why? Because it can give all the 5,000, but it cannot what? It cannot give beyond what he has capacity to give. So in that case, it means that the demand for this particular destination is what? Has been satisfied. The demand for this particular destination has been satisfied. So which means no other allocation can be done to what? This particular row column that we have. Now, the whole essence of northwest corner method is that if you notice, the moment we meet up with the demand the F5, there is 2,000 units what remaining is source one. Now, if you are doing northwest corner method, you are expected that you have to satisfy, you have to use up all the capacity of the first source before you move to the second source. So which means that for you to use up the remaining 2,000 units, you move to the right. You move to the right. And moving to the right, you are moving to the next destination point. And the next destination point is in need of what? 8,000 units. And you have two. So you give all that you have because you can't give more than what you have. So by giving these two, it means that what? This particular source has exhausted is what? Its capacity. It can't give any other thing. However, there is still a demand for what? 6,000 units of what? Of products from destination 2. And how do you satisfy that? So you move downward to where you have source 2, destination 2. So which is cell row 2, column 2. Now this row 2, column 2, if you notice, source 2 can give what? 9,000 units of products. The demand for that particular is what? Is 6,000 units. So northwest corner is saying give according to what they are demanding for. So you give 6,000 units of what? Of product there, while you have been able to what? Satisfy this demand. However, the capacity here still remains what? 3,000 units. However, the capacity still remains what? 3,000 units. So which means that this particular destination has what? Has been satisfied. So no other what? Allocation can be done here. Now, for you to now meet up with what? With the 3,000 unit that is still left for source 2, you have to move to the what? To the right. And moving to the right means that you have to satisfy the demand for what? Column 3. And to satisfy the demand for column 3 is demanding for what? 7,000 units of what? Of that particular product. And you only have 3. So you give 3 that you have 3,000 units because you can't give more than what you have. So by giving 3,000 units, we have exhausted the capacity of what? Source 2. However, there is still demand for what? 4,000 units of product from destination 4. So the question is, how do we meet up with what? The remaining 4,000 units of what? Of demand from destination 3. So we now move what? We move downward. And by moving downward, that means that source 3, which have 18,000 capacity, is ready to give what? The 4,000 units of what? Product that is demanded by what? Demand destination 3. So we give 4,000 units. It means we have been able to meet up with their capacity here, but there is still what? 14,000 units what? Left in what? Source 3. So then you move to the right, and by moving to the right, you'll be able to meet up with what? Destination 4, which is in need of what? 14,000 units, and you have 14,000 in your capacity. So by doing this, you will notice that we have been able to what? To offer a solution with respect to how best how best you can move your product from one particular source to particular location using northwest corner method. And how do you get your total cost? Your total cost based on this is you have your cost implication for moving the product, which is 19 per unit, then you multiply it that was then the number of units of product that was transported, and you plus it to what, to the 30 times 2, plus it to this 30 times 6, then you add it to what, 40 times 3, then you add it to what, 17 times 4, and the last one 20 times what, times 14. 20 times what, times 14. Look at this very clearly. Look at this very clearly. You should be having a total sum of 1,015. So if you are using naira, we say 1,015 naira. So which means that it's going to cost you this amount. But remember that we said that these particular units are in thousands. So the fact that they are in thousands, it means that it's going to cost you 1,015,000 naira in order to move your product from what, one particular location to what, to another particular location. Now you have to be very, very careful about these particular signs that we have here. Thousand. If you have been told it's thousand, you have to put it in what, the thousand. So if you look at this that we have done clearly with respect to northwest corner, it is very simple. It's all about geographical location of what, of your source and your what, destination. So the northwest corner method is only saying that, okay, if you are starting from this particular point, which is north west of this particular table that we have here, we are saying source 1 should be able to meet up with demand 1. Source 1 should be able to meet up with the demand that is closer to this. And the only way it can meet up is based on what, the capacity of that particular source 1. So the capacity is what, is 7. The demand by destination 1 is what, is 5. So you give what, 5 based on what you have, since you have what, 7. Since you have what, 7 with you. So by giving 5, you now have what, you have 2 left. However, you've been able to meet up with what, with the demand by what, destination 1. Then you move to the what, to the right side. To the right side, you move to the right side in order to use up the what, the capacity that you still have in source 1. Because that capacity must be exhausted before moving to what, the next source. So to use up that particular capacity, it means that you're asking yourself, what is demand destination 2 in need of? They are in need of 8,000 units of product, but you have 2,000 units. Then give what you have, which means that by that you have been able to exhaust what you have in what, source 1. And that later moves you to what, you move downward in order to satisfy what, in order to satisfy the demand for destination 2, using what, source 2, using source 2. And to use source 2, all you need to do is to ask yourself, to what extent can source 2 give you? Now source 2 can give us what, 9,000 units of what, of product, and destination 2 is only in need of what, 6,000 units. So we put what, 6,000. So by giving the 6,000, it means that we've been able to meet up what, with the demand for what, destination 2. And we move on like that to the what, to the last point, whereby we have source 3 giving destination 4 what, 14,000 units of product. So after you've done that, then you just put it into, so basically what we have here is more or less like saying your transportation cost is equals to, so when you have your 19 is gotten from what, C11, which is the cost implication of column 1, row 1, column 1, row 1, column 1, the cost implication, times the S11. S11 is the allocation that was made in row 1, column 1. So when you look at the C11 is what, is 19. The S11 is what, is 5. So all you need to do is just, so that 5 means what, 5,000. Remember we said that it is 1,000. So if you put it in 1,000, all you need to do is just multiply it together, and you start adding it up to every other places where you have what, where you have made allocation, and that will end up giving you what, this particular point that we have, this part, the total cost that we have. So with this, I have been able to explain how we can use northwest corner in order to provide solution to a transportation problem as we have here. Now we'll be using the same example to also do what, least cost method. We'll be using the same example to also do least cost method. All right. So now I said we'll be using the same example to do what to solve least cost method. Now remember that when we did northwest corner method, our total transportation cost using northwest corner method was 1,015,000. Now the idea is that with least cost method we should be able to get a lesser cost now because northwest corner method was justified based on the geographical location. Now, with least cost, we are looking at the cost implication of moving a product from a particular source to what to a destination. Now, we already know that these are the capacity of what of this source that we have here, and we also have an idea that these are the demand of this particular destination that we have here, and the different prices that we have at this top right corner are the cost implication of moving a unit of product from a particular source to a particular destination. Now, what is the whole idea with respect to what? With respect to least cost method. Now, least cost method is all about looking at the table that we have here and asking yourself, where do you have the least cost? Now, the point where you have the least cost, all you need to do is what? Give as much as possible that the source can give to that particular destination. And if you look at this table here, we have 19, you have 10, you have 8. So which means on this road you have 19 and 10, perhaps on this road you have 30 and 40, on this road you have what? You have 8. Out of all the least cost that you have here, where is the what? Is the least cost exactly? The least cost is here where you have what? 8. Because it's lesser than the other least cost that you have in all the other rows. So the question is that at this particular point, what are you expected to do? The least cost method says that what? Give according to what the destination is in need for. The destination point is in need of what? 8,000 units of what? Of product. The source can give what? 18,000 units of product. So you give what? 8,000 units. Now, the moment you are giving your 8,000 units, what you will notice is that what? This particular destination has what? Has been met. The demand of that particular destination has been met. So which means that we can't consider this particular column again for any allocation we are doing. Now, however, our capacity in this particular source 3 is going to reduce to what? 10,000 units and no longer what? 18,000 units again. Now, having done that, you are expected to what? To now ask yourself, where is the next least cost? The next least cost that you'll be considering will be looking at what? Column 1, column 3, and what? Column 4. The reason why you are not looking at column 2 again is because you have been able to satisfy the demand at that particular column. So there is no need of you looking at the cost implication at that particular point. So it's more or less like this particular column has been crossed off. So looking at the table, the next place where you'll be having your least cost is where? Is in column 4, where you have what? 10 units. 10 naira as it may be, in order to move one particular unit from the source to the destination. So the question is that what is the level of demand at that particular destination point? Level of demand is 14,000 units. What is the source? That source that can meet up with that particular demand at that point is what? Source 1. And source 1 capacity is what? Is 7,000 units as we have here. Now I'm saying 7,000, I'm saying 40,000 because remember we said demand and supply are in what? 1,000 units. So whatever you have here is what? Is in 1,000, it's not just 7. So which means that if demand destination 4 is in need of what? 14,000 and you have what? 7,000 from what? Source 1. You can't give more than what source 1 can give out. Now source 1 can only give out what? 7,000 units. So it's giving what? 7,000. And by giving out 7,000, it means that what? This particular point has what? Has exhausted all that he has. So since he has exhausted all that he has, it means that we can easily cross it off because we cannot be considering that particular route for any other further allocation. But what it also means is that destination 4 demand has not been met. Destination 4 demand now remains what? 7,000 units because we're only able to meet up what? 7,000 units from what? from source 1. So the next question is that you look at the table again, looking at this. Then you ask yourself, where is the least cost? The least cost is where you have what? 20 naira units per product. Now, 20 naira per product. Now, based on that, the next question is that what is the level of demand at this point? The level of demand at this point is what? 7. The source can give what? 10. So which means that we can easily give out what? The whole 7 that is what is demanded for. Why this source has what? 3 left, 3,000 units of what? Of product left in his what? In its capacity. But this particular demand has what? Has been met. So which means that this particular column 2 is what? This demand has what? Has been met, and we don't need to consider it for any further allocation. Now, we have a scenario whereby when you look at the table now, you see here you have 70, you have 40, you have 70, then you also have what? 40 here. Now, looking at the table clearly, when you ask yourself where is the least cost, the least cost can either be 40 or 40 here. So you can decide in a scenario whereby you have this, the tiebreaker can always be just try any one of it. So you can decide that you are starting from S2. Now, at this S2 point, the question is that what is the demand at that point? You have 7 as what? As the demand. When you look at it, okay, the demand is 7. What is the capacity as what? As S2? You have what? 9. So which means that we can freely give what? 7,000 units of product. Then it means that what? The source of this particular point is going to what? Remains what? 2,000 units. However, the demand for this particular destination has what? Has been met. Now that the demand of this particular solution has met, what we now have is what? This and this particular cell that has not what? That has not been met, that demands have not been met. So which means that if you are starting with the one that has least cost, it means you can only give 3,000 units, and the demand for that particular what? Destination is what? 5,000. So you give 3, then source 2 is going to give what? The remaining 2, and you give 2,000 units. For a recap, if you look at this particular problem that we've been able to solve using this cost method, what we have been able to do is that before solving it, we ask ourselves, where do we have the least cost? The least cost with respect to moving a product from a particular source to another destination. Irrespective of wherever that least cost is, we are only interested in where is the least cost. Now, based on that, we found out that the least cost is what? Is 8 naira out of what? Out of every other cost implication of moving the product from what? One point to another. So at that particular point, the next question we ask ourselves is that what is the demand of that particular column? The demand of that particular destination is what? Is 8,000. What is the which of the cells do we have? Which of the cells that we have here can meet up what? With the demand at this particular cell? The only source that can meet it is what? Is S3. And S3 can give what? 18,000. So freely we can give what? Our 8,000 units of what? Of product. And that is going to lead to what? We having what? 10,000 units of product remaining at this particular source. However, the demand for what? Destination 2 has been what? Has been met completely. So which means that we can't consider that particular what? That particular point of what? Of destination again for any other allocation. Now, the next thing we ask ourselves is that where is the next least cost? And found out that the next least cost is at what? Point S14, where you have what? Where you have 10 units as the cost of what? Moving one product to what? One place to what? Another. Now, at this particular point, the next thing you start asking yourself is that what is the demand of that particular destination, and which of the source that we have here? We still have the 3 sources with their capacity there. We have 7, you have 9, you have 10 as it may be. And you ask yourself which one of these, notice that S1 can be able to do justice to that. So how, to what extent can S1 do? S1 can only give what? 7,000 units. But the demand is what? Is 14,000 units. So the next thing you ask yourself is that, okay, if S1 can give 7,000, why don't you just give all the what? All that he can give. So 7,000 units is being given out there. However, the demand still remains what? It still remains 7,000 units. Then you ask yourself, where is the next point of location? Again, you notice that is what? The next point where you have in this cost is what? Is at S3 and 4, where you have what? 20 naira as the what? Cost of moving a product from one place to what? to another. Then you look at what is the demand at that particular destination. The demand that remains is what? Is 7. The source capacity is what? Is 10. So you give what? You give 7,000 units. Now what it means is that we kept doing that over and over and over until we're able to do the what? The whole allocation, which means that we're able to exhaust all that all the sources have, and with respect to meeting what? With respect to meeting the demand. So which means that the cost implication for this particular method is going to be, so if you look at it, before the initial was what? C11, S11. But this one is going to be what? C14, S14. Because this is where you have what? Where you have allocation with respect to this particular road. So at that C14, S14, what you have there is what? What we have there is 10 times what? 10 times 7. And you continue to do like that for what? Every other cell that you have there. So which means it's going to be plus 70 times what? Times 2. Plus 40 times what? Times 7. 40 times 7. 40 times 7. And say plus 40 times what? Times 3. Plus 8 times 8. And we have plus 20 times what? Times 7. Plus 20 times what? Times 7. Based on this calculation that we have here, we should be having a cost implication that is around 814,000. 800 and what? 14,000. Now, remember when we did the northwest corner method, we were told that the cost implication is going to be 1,015,000. But now with least cost method, using the cost as what? As a factor to allocation, we can see that the cost has reduced drastically to what? 800 and what? 14,000.